All right, good morning, everyone. Welcome to Autodesk Virtual Academy, brought to you by your friends here at KETIV Technologies. So today we have Javier Chavez on. Jav, how's it going?
Good. I'm doing good. And let's talk a little bit about the agenda for today. We're going to give you guys a quick overview of what the utilities are, how you get them, so forth. But the main part of this, the main focus of this are the two next bullet points, which are, creating a facility layout, right? A lot of us need this to basically plan for our facilities, to, make sure that we use, our space efficiently, and sometimes to implement either new tools, new machinery, new workflows within your facility. So we'll talk a little bit about that, but we'll also get into creating assets, which is a key part of all this, is creating those assets that you're going to use, your equipment, the things that fill up your building. Okay, you're going to need to basically keep track of those, order some of those components at some point. So that's key to all this. You don't order a building, so you don't need to keep track of that, but you do need it in order to find out what your design envelope is, what are your constraints, space-wise and so forth. Okay, we'll review this, and we'll also have a little bit of Q&A. All right, so first things first, right? Why would you want to do this? What are your goals in terms of doing this? For most companies, they want to grow. Right? There's no surprise here. They want to grow financially. Sometimes that means in terms of building capacity. So sometimes it means, commissioning new facilities to meet these logistical needs, reduce shipping costs, and maybe meet local demand. Okay. In other cases, it means maybe revising our facility layouts to support higher output. Okay. So maybe same facilities, but new machinery, robotics or automation to support higher output. That means, we got to add electrical lines. We have to add spaces or fencing to support this, right? They also want to optimize, right? We want to optimize whatever we do within an organization. If we're doing it for our company, we want to do this as efficient as possible. So when it comes to our facilities, we want to ensure, efficient use of the space that's in there and maybe strategic placement of our equipment. In essence, we basically want to plan and design a more efficient factory, right? And the last thing there that I, have seen in speaking to customers, they want to be adaptable. Okay, right now these times are a good example where we need to be adaptable. We need to be able to quickly change and pivot in order to implement changes, either in response to market pressures, a number of things, and we have to be adaptable in order to sustain long-term growth, right? So with that said, some of the challenges there when talking to customers and identifying some of these issues, right, that come up as we try to manage our facilities. The first one is just inefficiencies in design process. The time of a manufacturing engineer, it's valuable, right? And so it's wasted with inefficient tools a lot of times. 2D kind of gets the job done, you can see here, but how much can you tell, how much can you see in that 2D drawing, right, that 2D plan view? So it sort of gets the job done. You're probably using AutoCAD right now if you're not using the utility. It gets a good portion of it done. You can leverage a lot of information, but you can glean so much more and communicate so much more by expanding that, right? So they're really not able to contribute to the maximum potential, right? The other cause is, or issue that the challenge that customers are seeing is the inability to test the designs. What can we do here, in the traditional 2D and work environment to see if this is the right place to put a work cell or the right order to place an operation, right? Or even test the installation sequence. Can we actually put in a piece of machinery before a wall goes up, right? It might need to go backwards if that machine is just that large. Okay, so these are critical to know, beforehand, especially, before you actually do any construction in the building or any new construction, right? And let me go back and address too, I think probably the most obvious one there, poor collaboration. Okay, there's so many people involved in a project like this. You got architects, you got, contractors, you got other stakeholders. And what ends up happening a lot, at least what we hear from our customers, is that when they're dealing with the construction, right, they deal with issues that they couldn't see together. Everybody's working in an isolated environment. You got structural engineers working on their drawings. You have the manufacturing engineer working on his drawing. And then you've got other people creating some drawings or engineering data for some of the machinery that gets placed here. Okay, so those are some of the challenges. And the way we address this are with some of the tools. We have factory utilities. They're available to you within your product design and manufacturing collection. And I highlighted there the utilities on top of AutoCAD, Inventor, Navisworks, Vault, and Recap, and Revit, because they sort of work on top of these tools. Specifically AutoCAD, Inventor, and Navisworks. There's toolbars that get added in, right, to improve design efficiency during this process, to improve site planning and identify other ways to improve the factory efficiency. Right, and so they enable better collaboration with some of these higher quality visualization tools like Navisworks. We have better ways to validate our designs by putting them through tests or analyses. Right, so this is the way we address it. You've got this within your toolbox. It's built on top of tools you probably already know or are familiar with. It's just that extra set of tools that these utilities add in. And to make things more interesting, they all interoperate or work together. Okay, so let's take a look at the workflow, right? The workflow starts off early in the process with the simplest thing, which is just conceptualizing what it is you're going to do, right, within the building. Maybe it's just a cell you need to improve instead of the whole building, and you want to plan for that, right? So it'll start off that way, and then once you have an idea, a direction, then you'll start actually doing the work, the actual drawing in 2D, using blocks and information that maybe you glean from other stakeholders, like exported files from Revit, floor plans that you might have on hand. You'll start doing that in 2D and creating a rough layout. Now, the nice thing about starting in 2D is that you can glean a lot of information from it. There are analysis tools that live inside the 2D environment, and it's quick, right? So one of the things you'll need to do is just get that building information. So whether you're working with an architect or you have some internal building information and it's just 2D AutoCAD, get that information. The more information you can get, the better or the more informed decisions you'll be able to make in terms of placing these components and deciding what to do with them. Okay, we've had customers go through the layout process for a new facility and suddenly change their mind about implementing or purchasing a facility just because equipment didn't fit. Okay, so that's the main thing you're going to start doing in that 2D layout, is start putting in your equipment or your assets. So I'll refer to those as assets. And at some point, once you're fairly certain of the direction you're going in terms of your layout, you're going to want to convert that to 3D. Okay. Why convert it to 3D? Again, we're going to glean even more information from that. We'll be able to use this to do clash detection or identify any interference between components. We'll be able to simulate the construction timeline. And of course, at some point, you're going to have to create drawings for all this. You'll have choices on where to create your drawings. You can do this in Inventor, right? Or in AutoCAD, and in some cases, both. AutoCAD lends itself to the architectural environment. So if you have to deal with municipalities or anything like that, it makes sense to create architectural construction drawings, things you can send to municipalities in AutoCAD. Okay. If you need a live active bill of materials for your drawings or your engineering data, you might want to document that in Inventor, because that's one of the things it does. It gives us a good, nice, clean list of bill of materials. Okay. So let's talk about the conceptual part of this. And for this, I'm just going to go ahead and play the video. The rest I'll actually demonstrate and show. But one of the tools included with the utilities is Process Analysis 360. So the tool is cloud-based, even though a portion of it runs on your computer. And if I go ahead and launch this now, what the goal here is to simulate what we want to do with the tools we want to do it and with some of the resources we want to do it. Now, it doesn't take into account distance or spatial information, but we can import information that we have from the shop floor. So if the shop floor has a welding cell, right, and we're trying to improve it, we want to go from manual welding to a automated process, they might have takt times, they might have uptime percentages for that station, or desired uptime percentages, desired output, and there's some information here, right? There's some processes here. We have to load parts. They might go in a bin, they might get held for a little while, and we might have to load multiple parts and then weld 3 or 4 parts together, okay? Once they're done, they go somewhere else and get stored, right, in a bin. So we can import that type of information that gets captured maybe on the shop floor to do that. So in this case, what we're gonna do, or what the goal is, we wanna go from a manual welding process in a cell on the production floor, and we wanna just see what happens if we go from a manual process to robotics, right, and implement robotics. So this is going to generate sort of a flow chart. You could do this manually without the spreadsheet. In this case, we'll load the spreadsheet up, and those values get loaded in the chart you see here. Now, the objects you see, the block diagrams you see, are representing either sources of for the process, processors. So think of machinery, think of areas where things happen and things get processed, whether it's a machining process, a milling process, a packaging process. That's how they get categorized. So you can see them here on the left. They can get categorized as sources, and we have 3 sources for parts and a processor that happens here. So there's a fixture, right, that gets set up. The gear kind of matches the processor there. And then it goes to a secondary process, which is the welding cell. So it goes into a fixture, goes into a welding cell, the 3 parts do. And we're trying to simulate in the welding cell what's going to happen, what's going to be our output when we automate this a little bit, right? This is going to help us decide, do we invest in a robot at all? Do we need 1? Do we need 2? Do we need 3 to meet our goals? Okay, there's other objects that are categorized as buffers. They're just kind of holding places. Sometimes a buffer is a pallet that's simply stacking up until we've got 50 of these welded components, and then they move on to somewhere else. So there's products, and there's people, there's operators, right? So in doing that, you'll start to see that, you know, we can also connect our CAD data to this. So this is connected to our factory assets, and if we have, you know, CAD data that basically represents some of these machines, we can connect that so that we can utilize it later. So right now, you know, we're just adding some bits of information. How is this happening? Is this, you know, happening in an order? Is it going to happen over, you know, a number of days? Or do we just want to simulate what happens in one day? So with that said, you know, we're simulating this. You can control the speed of the simulation. But let's see, let's go ahead and fast forward here just a little bit. And run that again. So when we actually run the simulation, we'll see, you know, what is blocking us from making any progress on this, or what's the roadblock, okay? And at the end of this, I'll pause it here for just a second. After going through this process of gathering parts, putting them in a fixture, you can see some exclamation points. There's something that's kind of a roadblock here, and that's the welding cell right now in this case. Afterwards, it needs to be unclamped. That's a process that needs to happen. It needs to be unclamped, and the chassis for this component that we're building is completed and placed over here, okay? We only got 73 done in a day. Okay, and the welding machine, as fast as it is the roadblock. So it's going to be easy enough to simulate, okay, well, what happens if we purchase a second welding cell and also start moving some of that product, right, some of the components and basically divide the work. Okay, so if you're familiar with Visio, it kind of reminds me of Visio or some kind of flow chart type of tool. But you can see here in this case, we've now changed our output to 113 just by adding that second robot. And there's some other challenge there, another blockage. But you can also create reports so that you can kind of analyze this, look at this on paper, and look at the numbers. Okay, this is all before drawing anything. It takes minutes to put together. It's not taking into account distance, but it does take into account transportation methods. So I mentioned, that asset browser exists here. It also exists in AutoCAD and Inventor, and we can basically relate our AutoCAD data or Inventor data to those objects, those block diagrams. Okay, so now that we're done, we can actually generate a drawing that gets used as a starting point for that cell, that welding cell. Okay, and so we're exporting this information. It'll create a drawing. It doesn't really know where these should be, where these bins should be, where the robots should be, but it is going to insert geometry so that you can manipulate it and maneuver it later. Okay, so we're going to go ahead and export that to a DWG file, and we should be good. Okay, so let's move on to the next part of this, right? This is the part we're going to go ahead and walk you through, is actually creating the layout, the AutoCAD 2D portion of it, and then eventually asset creation. So if we jump over to good old AutoCAD, and I can show you the drawing that got created. Let's go ahead and open that up here real quick. There we go. And so here's the drawing that got created just a moment ago. And I've already opened it up once, but if we take a look at it, it contains geometry that represents the welding cell or the welding itself there, other machinery here, some of the bins that were there. Now, when it creates this, it doesn't know where this stuff should be. So they end up, all over the place or on top of each other. And, it's your job to kind of rearrange this the way you want. In addition, I've already added, some fencing here, a couple conveyors, and so on. Okay. So that's just one cell. Within the factory, let's see what that looks like. So within the actual factory, this is our sheet metal production factory where this is going to get welded up, and that cell needs to go here. So we're just going to insert that drawing within the overall factory, and as somebody creates this information or gathers this information, you've got tools here that'll help you draw things like walls and 3D architectural objects. This adds on top of AutoCAD architectural. So if you want to do this in AutoCAD architecture, the benefit there is that you have some tools that'll let you draw in 3D and create walls and windows and some of the architectural elements. And obviously, if somebody's supplying that to you, there's less work for you. Okay, so let's go ahead and insert that same drawing here as a external reference. Okay. And I'm going to go place that right about here. And I can just use good old AutoCAD commands here. Okay, so this is one welding cell here. I'm actually going to duplicate this and just use good old AutoCAD commands. And maybe put these a little bit closer together. Okay. And this does go in the building. So at this point, I've got my cell that I've already done some analysis on in terms of process. And now I need to decide, well, how does this cell fit into the building? So I could take the two, welding cells here together and place them right about here. Okay. So I want to make sure that, these exterior walls, I'm not interfering with those. I also maybe want to add some more geometry here, more assets, right? So let's go ahead and take this and move it just over here to the left, because I can see here I'm going to have some interference. Okay, and let's start adding some stuff. The same asset browser that we saw in that early part of the process exists here in Factory. So Factory adds these tools on the Factory tab up top. Everything else is the same as AutoCAD Architecture or regular AutoCAD or AutoCAD Mechanical. This Factory tab gets added to any one of those tools that you decide to use, and it gives you options that are specific to putting together a factory. So this is one of them, the asset browser. So this asset browser contains existing assets. You can create your own library of assets. In this case here, I need to take into account some overhead electrical cabling, and so I need a cable tray. I'm just going to do a search for cable tray here, and I have individual pieces. I also have something that's called a chain, a cable tray chain, and anything that's a chain can be inserted as sort of like a polyline and then converted to a set of cable trays. So these will connect end to end, and I'll go ahead and drag that in. Okay, and it's asking me for a start point. So that cable tray needs to basically live here, and I'm just drawing a polyline. Okay, and the cable tray is actually going to be suspended up in the air. So this is just a polyline, looks real thick, but later on when I convert this to 3D, it'll actually show me in detail the cable tray. So this is just taking up some space, and I can tell overhead what's going to reside there. In addition, I think I'll probably elevate this because this gets inserted on the ground. Let's go ahead and put that up just a little bit higher in terms of elevation. Okay, so this is a metric drawing. I'm going to put it 3,000 millimeters up in the air. And so if I rotated this, saw this in 3D, this would actually be elevated. Now, the other things that need to get added in here, I'm going to go ahead and work on this. This shows up as an extra. And I'm going to add more to the cell. Okay, so let's go and edit the cell. Okay. And I'm going to look for other conveyors that maybe get added onto the end here. So I'm going to look specifically for roller conveyors. And when I look for this asset and I do a search for it, you'll start to see in the results, some of these have bubbles. These are cloud-based assets that people are sharing out there. So you got a good library of existing machinery, equipment. I mean, if you were to look up, if you need a CNC machine and look up Haas, okay, here we go, H-A-A-S-S or single S, and there's Haas equipment there. They've published this out there so that you could get a good idea as to how their CNC machines will fit in your environment, and you can basically download them, drag them in here, and you've got a 2D, 3D symbol of that. So let's go back to our rollers, which is what I need now, our roller conveyors. Okay. And again, the ones with a bubble are on the cloud and have to be downloaded. Let's go ahead and bring in a straight conveyor. And what you'll find is, depending on how these get created, they have connectors. So you see the green dots, they will go together like Legos. Okay? So you can connect them after the fact, so you can actually keep them here and then connect them after the fact. I'm actually going to bring in a curved one here first. Okay, and depending on how you connect it, it could turn left or turn right, just depending on the end you're connecting. Okay, so a couple more assets, and then let's go and get in a straight one here. Okay, so I'm starting to get a good idea as to where things are going to be within the facility, and ultimately, what I want to do is just kind of quickly prove this out in 2D, because it's quick, it's easy, it happens very quickly, and then make my way towards 3D. Again, I'm going to be able to get more information from this. So just an example of the type of information you can get. There's further analysis tools that you can run inside of here to now consider distance. So let's go ahead and maybe open up another file here. And let's open up, let's see. There we go. A different area here within the facility. Okay. Okay, again, just 2D geometry, it's not 3D yet, but this gives you, the factory tools give you a place where you can define stations. So you can see, here's our chassis station. Here's an engine station, right? And this is for an ATV. So if I didn't mention that before, it's for an ATV assembly line for an ATV. And we were trying to, optimize maybe the sheet metal environment where we create the chassis or weld up the chassis. But this is where maybe the wheels get assembled, tires, so on, okay? So we can define stations in here. We can define products, okay, to run through here and run some analysis. So each product, we have a quantity associated with it. The stations actually have values for uptime percentages. And then we can tell that product to run through each station. Chassis first, engine second, wheels, tires, and so on. Okay? And we can run transportation analysis. So if I'll start with machine analysis real quick. Okay, there's two types of analysis, machine analysis, and we can see, are we overburdening some of these stations? And you can see area number 1 here is a place where maybe we're overburdening this station. Okay, so I believe that's operation 3 where the wheels get assembled, and we could see here and sort of do what if scenario. Right now, the processing time for assembling the wheels here is 15 minutes, and there's a setup time of 5. Okay, so we're going to dump that down to 3 minutes, and the setup time is really maybe 1.5, or maybe we're proposing to make a change that makes it 1.5. Okay, and you could see in this meter, we just went from being in the red to in the green. Right, so suddenly that station is no longer overburdened, and the same can be said for the path that this takes. So if we do transportation analysis, okay, again we've got tools to let us see how far are we traveling from one station to the next, right? And how long is it going to take, based on how it's moving. In this case, it's a conveyor system. So when we start to look at this, these operations here for this assembly of this ATV, of the Vimic ATV, you can see here as it goes from this 3rd station to the 4th, a conveyor moves this at a certain speed. And so if we want to affect this, maybe we can speed up the conveyor at that point or so, but we can change the travel speed and so on, and just get some more information before we move on to 3D. So I'm going to make this a little bit faster, and I'll double it just so you can see immediately a change. Right. So we've had some numbers change, update here. We can go to every station and kind of speed up the travel process here. Right, and the time's going down. Okay. If we wanted to change the distance, then these objects that make up the stations can just simply move closer together. Okay, and so those are the types of analysis that we can see. If I come back to the sheet metal production cell, I think it's time to make this or turn this into 3D. Right, and you still have the regular tools to create a drawing out of this inside of AutoCAD and use your layouts and so forth. But we're going to go ahead and start seeing what this looks like in 3D. So right at the very top, we got quick ways to just open this in Inventor. Okay, so I'll do that here. Right, and it's going to take a lot of those assets that we put in, our equipment, even though they're only 2D here, if you see it on the right-hand side as an asset, it's got a 3D equivalent. So we're going to leverage that here in just a sec. And you'll start to see our 3D model get put together. Now, traditionally, if you guys think about this, you know, if you had to build your own 3D layout from scratch, you have to define a floor. You have to constrain everything to the floor, and then you have to start positioning these objects, right? And maybe constraining them to each other. So it's thinking here. I'm going to come back to Inventor, see if it's starting to show up. And we'll give it just a moment here. Okay, it's asking me to save, so we'll do that. There we go. All right. So I'm curious, Nigel, any questions coming in on the chat?
Nothing right now that we need to address, Hav.
Okay, sounds good. Yeah, keep, you know, ask some questions there as we go through, but it is syncing up the 3D with the 2D. And whatever changes I make in the 3D file, they'll go back and sync up with the 2D as well. And there'll be one more element of this, right? Later on, when we want to present this, you'll see, you know, in AutoCAD and in Inventor, a way to open the same layout in Navisworks, right? And maybe now start to share this outside with outside stakeholders or review it with outside stakeholders. We'll take a look at that as well.
And then too, real quick, Hav,
Yep.
just for some people, what's the best place to find like sample data sets and stuff for things
Good
like
question.
Factory?
Good question. So on the Factory tab, whether you're in Inventor or AutoCAD, there is a shortcut, and I don't see the Factory tab just yet. It's not showing it to me just yet, to the help, the factory-specific help. And I'll show you that in just a moment. And once you go there, right at the top of the help, there's some tutorials there, okay? The other thing you're going to want to consider is we have done productivity training on this subject, a good 3-4 hour training session on the basics to, you know, put a layout together. And we're about to do another one next week, July 15th, okay? The next one is going to build on top of the previous one, and it's going to focus more on Navisworks and how to best utilize Navisworks to do some of this.
Absolutely. And then another question to have, and this comes up a lot when I talk to people about Factory, is what happens if you need to work off of multiple like XY planes? Say you've got a multi-story facility, or you just have things at different heights.
Okay, so each layout you create can have a different elevation. So there can be multiple layouts in one file, and one be the second floor and one be the third floor. Or you could divide it up at the same plane. And if you have a very large facility, it's going to become very hard to work on, maybe even clumsy, if you will, just because it's so large, right? And a lot of us have had experience with that, and I think I just crashed Inventor. So we'll see if I can just open it manually here. Bear with me. But it'll, you can divide a floor plan into sections, and those end up being separate layouts. Okay.
Yeah, so there's
one
a
of
couple
those
of
separate layouts can be worked on by separate individuals.
Just have Hob fire this up real quick.
Yep, and let's see if this will open this way.
No worries. And then for people who are using Vault too, I know that's like, well, where do I store these assets and things like that? When you start involving Vault with all of this, there's a very specific way to manage the assets. So you're going to want to make sure to check out some of the documentation for that. So if you just search Factory Design Utilities plus Vault on Google, you'll probably find our webinar that we did on it. in addition to some Autodesk documentation on how to set that all up. Essentially, if you set it up right the first time, you don't have to worry about it moving forward. Cool. And like I said, if anyone has any questions, go ahead and type them in, and we'll go ahead and address those at any time. I know that there's multiple streams going on too, so I have to manage all of those. Just make sure that there's not things happening on multiple fronts. So
yeah, I'm not sure why that's taken as long as it is, but while that's going, let's, yeah, there it is. Okay. So there it is. I mean, it converted, some of the stuff that we added here, the curved, the straight conveyors. There was some that were already existing here. It converted them to 3D, and you can still see the 2D AutoCAD layout. It's in here. It's in here. Here's a sheet metal production drawing. It lays on a floor, and if I zoom away, I think you'll be able to see that floor here. Okay, and so as I go to add more things, right, I'll be able to see, whether they hit other things. Like I see a column here that's kind of close to being interfering with some of these other components. That's all stuff that got created in AutoCAD architecture. So that is, 3D geometry that we can leverage here in this environment. We didn't have to create a building. It's something that we just had in AutoCAD architecture. So some of the other machinery, if you notice a cable tray here, I drew as a polyline, and it drew a standard segment, and then, right here, there's a non-standard segment, and it highlights it in red. Lets me know that, yeah, that might be a custom cable tray segment that I might pay extra for. So when I have situations like that, right, we'll be able to see that. And it is elevated. You can see it's elevated above the facility there. So we could continue the process. There's more stuff we need to add. I'm going to look for in the asset browser, same thing we had before, a jib crane. Okay, and in this environment, since we're in 3D, it's going to be pretty easy for us to basically maneuver this or place this on the floor here. It automatically recognizes the landing surface from the jib crane and mates it to the floor. So it's actually sliding around on the floor and is ready to go. Now afterwards, I have the option, to maybe modify the placement and rotate it, put it where I need to here. So we'll play with that here. But I get tools to basically start, working with some of that. So here I'll go ahead and rotate this out this way. And place that there. Okay, so I've done placing the jib crane there. In addition, right, I mentioned how these connect, and you guys got to see those. It's, one product getting connected to another product. Sometimes what we see is people using Factory to configure an existing or create a configuration of a product. So I'll move, to a different area just over here, and I'll show you an example of that. Okay, and get to maybe our custom library here of equipment. Okay, and we'll bring in a Fanuc robot. Okay, so if you guys are familiar with these robots, you can see here, there's a connector at the bottom, so it can sit on top of a platform. In fact, let's go and put the platform in here first. Okay. Okay, and then we'll move on to the robot. The robot will sit on top of that. And based on how you publish this, you can go ahead and make this connect in such a way that, really what you're doing is configuring a product, right? A modular set of products. So we've had customers do this just for basically configuring a product here. So there's a connector there. It connects like Legos. There's another sphere here. And I can put multiple ends on this robot. So if I drag this box gripper, right, the box gripper connects at the end, or I could replace it with a pallet gripper, right? And suddenly I'm configuring the robot to do different things, or maybe even sell, you know, if we're in a sales environment, create a different configuration of what it is I'm proposing for my customer. Okay. So this is key to all this. And the way we get to this, or the way we create these, this is one of the things we're going to focus in on some of or we have focused in on some of the productivity training. So take a look at it if you are able to access the productivity training. But we'll go ahead and open up an example and just show you how that gets created. And best practice, right? If you're going to create an asset, something you're going to reuse in a large factory, simplify it. Okay. So I'm going to start with something that's already been simplified. Okay. This has been dumbed down to basic rectangles, slots, rounded off objects, but it's not very complicated. It's a single part, but it represents an assembly. Okay. And in order for this to slide around on the surface, connect to other conveyors, we'll draw it up this way. We'll make sure that we have parameters that control, you know, things that are important to us. So there is a length parameter, there is a height parameter, there is a width parameter. And one of the things we'll do that's different is in the parameters dialog box, we'll mark them as key. That means we want people to be able to modify this. In some cases, we could add intelligence that limits how they get modified. So this has to be a 28-inch, 30-inch, or 36-inch. You know, we are not going to allow other people to create, you know, deviate from that. Okay. So that's there, ready to go. The process looks like this. When you're in a part, you have your 3D modeling tools, you have sketching tools, but in a factory environment, you have the asset builder, or you have a create asset tab, right? Either one of these will help you get into this environment where you can say, how's this going to behave? Okay. Now, immediately I get a different set of tools that lets me decide how this is going to behave on a factory floor. Okay. This plane that you see here is the floor. It's going to land, you know, sideways like this, halfway embedded in the floor. I got to tell it to act differently. I'm going to create a landing surface. I'm just going left to right. And let me re-specify that. There we go. Okay, so the bottom of the foot represents what the floor is going to touch. Okay, I can give this multiple insertion points, but it's going to use that corner right now. I can offset this from the floor. So if it hangs above the floor, or it, you know, it kind of gets elevated somehow, I could offset that. But for right now, this works. That is the floor. That's where it makes contact with the floor. Okay. Next step, define connectors. You can see I've got work points that coincide with the top surface of the belt, the front face of the conveyor system, and the center of the conveyor. Okay, so there's a work point there. You're going to need to create those and define that as a connector. So there's one at each end. Okay, and as soon as you define it, you're going to have to tell it what's the orientation here. And this basically always needs to point away from the machinery. The blue represents up, so we can select it and redefine it perpendicular to maybe this surface. Okay. I'll right click, choose OK. I've got a connector. In addition, that connector has some very cool features. A little bit newer here, you can assign colors to these. And in 2021, you know, green is a universal color. It'll connect to anything. But red, right, will only connect to a red connector or the universal green. So you can make it so that these don't connect to just anything. They connect to very specific things. Like the robot had gold connectors, it only connected to gold connectors, right? So you can make this maybe a certain type of conveyor that's only compatible with another. So I'm going to leave that universal. Okay, we'll go ahead and define this pointing away, and define the up, direction here. Okay. So when these connect together with other conveyors, one of the things we'll need to do is decide, what properties or what parameters are going to talk to each other. So we already know we're going to give people the availability here to modify the length, the width, not the leg information, right? That's another parameter. We can put in tooltips here so that people know what they're modifying. I think length, height, and width are pretty self-explanatory, but we're going to expose those to people. You could also create limits on those like we did with the width. So placing a check exposes that, and then we're going to go to this connector class property. So that if we have connectors, one of the things we'll want to do is tell it, well, what kind of object is this? Okay, and there's a option here to specify conveyor. And within conveyors, there's different types. And so we could tell it if this is a normal, inclined, or a spiral. And depending on which one you choose, this is optional, but this helps a lot. If it's a normal, there's a requirement where it needs length, height, and width. If I were to set this to inclined requires different parameters. And if I were to click add and click OK, I think it would bark at me and say, hey, you're missing a couple parameters, the upper height and the lower height for the connectors. So I can't do that one successfully. I will be able to do a normal, right? And click OK. Those parameters will connect to other ones, and they'll communicate the width or the length when they change. Okay. We can put in other properties. We can make sure that we put in part numbers, and we could also make it so that the part numbers update. So here's a part number. We can put in iLogic so that the part number updates based on the width, the length, the height. There's all kinds of information we can put in here. As a process, if we ever drag this into that first process, we can classify it as a buffer, operator, processor. In this case, it would probably be a processor. Okay. And there's ways to control what it looks like in 2D. So you can work with layers, things like that. Now, this is going to create a 2D object out of this. I'm not going to get too deep into this information here, but I'm going to go ahead and publish it now. Okay. So I'm going to publish the asset. It'll ask me to save. Okay. And I could put it in my own personal folder here, or put this in this library where everybody can see it who's maybe working on this project. Okay. So it'll show up in my asset library in just a moment, and when I come back to my facility here, I'll leverage it or use it. I'll start to connect them together, and you'll see how we can basically make those properties propagate one to the other. Excellent. Okay, so we'll test this out here, right? So I mentioned you can kind of separate these layouts here. I'm going to open up this layout, which is actually a separate layout embedded within the other. Okay, and I'm going to take this conveyor, and when I do that, I see the properties that are exposed. So whoever published this, decided we can change the height, right? We can change the width. There's a number of things we could change, just like the one we created. And I'm going to go ahead and change this to 42. Okay. So just the one conveyor, it's attached to other 28-inch conveyors, but if I change that to 42, right, it'll take a second here. It's going to change the one, but it's also going to change the ones that are connected. That's what those connectors pass on when they're connected, is that information. So it's going to hide for a second here, and I'm hoping it's still up. Nope, it looks like it killed it. So I'll probably just open up a smaller assembly here to work with this.
And we're running pretty long on time, Hop, just FYI.
Okay, got it. We're at like 57?
Correct.
So one of the last things we'll do, I'm hoping to get Inventor up here, but in the meantime, earlier was a way to basically get this into Navisworks. Okay, and so in Navisworks, if you convert everything you have in your layout and get it into Navisworks, or you aggregate data, so you could just take your layout and get the architectural data and bring it in here. That's what this tool does. You could basically go and append more data and look for buildings. You can see it's going to read a number of files here. And what you're getting to here is a way to hopefully communicate, okay, what does the entire factory look like, right? And so we can do a couple things. We can go to, we can create things like walkthroughs. So there is a recorded walkthrough that we can go through here. And we could actually start walking through the facility. So these are the same objects that we would see, in that layout environment in Inventor or in AutoCAD, but we're seeing a lot more detail. Okay, and we could literally start walking through the building here. Okay, and we could also do some, this is the tool that we would actually use with customers and share this. There's a free viewer for this. So you can publish this and save this as a NWD file. Okay, this is a file that's all inclusive. It has everything you possibly need to see what we're seeing here in one single file. You don't need assemblies, you don't need AutoCAD drawings, you just need this one file. If you share this with a customer and they download Navisworks Freedom, they can open up that file without needing a license. It's free. And they can walk through the facility just like we are. Okay. So the other thing we can do here, I'm moving to a different part of the facility. Okay. Where we can start maybe looking at a different area of the facility. And I want to do a little bit of clash detection. So we'll start it back over here again. And we can bring out a separate tool to do that. So over here, we're basically going to tell it, okay, there's three, packaging lines or lines. We want to see if any of those lines interfere with the buildings. So we pick them here, right? These are the things that got transferred over from Inventor or got appended into this Navisworks file. And we're looking for any interference. You could set up rules, okay? And tell it to show anything that's within a certain distance. So once we have that set up, we can just run that test. And immediately it finds, okay, here's clash number 1. It highlights it for you and shows that this exhaust is interfering with a beam. If I go to clash number 2, okay, we can zoom out here and there's a fence interfering with a column, right? And if I go to clash number 3 here, okay, more interference with another exhaust and maybe some other objects. Okay, that's ultimately what you want to get to, is finding out that information before you build. And at this point, if you find that information, you can decide, do I need to move my exhaust, or does the structural engineer need to move some of his columns? Okay, so anyways, it looks like it actually did not go away. So it actually, modified a couple of these. I thought it crashed. It did not. It just was going really slow. But it modified, the ones adjacent. That's what we were looking for in terms of that, is, having or creating these to where you have parameters that pass through onto like components. Conveyors all need to talk to each other, so we made them talk to each other. Okay, so we're running out of time. I'm going to go ahead and jump back to my presentation here, and hopefully we could answer some questions here. But a quick review, right, in terms of what the tools do for you here, right? We saw, we can go to 2D, or even before 2D, is start to plan for our facility by just making some quick decisions on how many machines we're going to need, how much we want to process at a given time. and decide early on, do we need, 2 robotic welding machines or just 1, right? And so that begins the 2D layout that's pretty quick and easy. We're all used to doing that already. And then, once you have the 3D inside of Inventor, you could easily get that to, or use that in a meeting, in a presentation environment to start to communicate what you're actually proposing, right? And if you think about what happens outside of the company when you're working with other stakeholders, contractors, that's pretty important. If you can bring in their information on top of that and make decisions like, who's going to move the column or who's going to move their exhaust to eliminate that interference, that's what you want to do, right? And of course, all of that, works towards validating your plan for the facility. So,
again, thanks, Hav, for joining us today. It's always a pleasure working with you on these. And I can't wait to the next one.
all right, thanks everybody.
Cool. We'll see you all next week. Bye-bye.